a bit for okay, go live. Going live. Okay. Okay, we are live. Hello, everyone, and thank you so much for joining us today for this very interesting ERC 721 workshop that's going to happen. That's going to start in just a couple of minutes. Before that, we have Brian from Screenshot Labs, and the motto of Screenshot Labs is that by empowering creators, they aspire to onboard the next million digital asset owners. And I'm going to let Brian talk about his project for a bit, and then we'll have Robert, who you can see on screen, join us to walk through the ERC 721 contract, which everybody has been waiting for. So, Brian, it's all yours.
Okay, cool. Well, thank you very much, guys. But if you don't mind, I will actually share you my screen, so it could be
Mhm.
a little bit easier. And please feel free to interrupt if you want to ask questions or whatever. I guess we can do it this way as well. Let me know if you see my screen well.
Yes, I've added your screen to the stream, so you should be good to go.
All right. So should I go? All good?
Yeah, all good.
All right. So, but I can make you a little introduction. So, basically, I'm Brian Sisak from Screenshot Labs, or Evrai team. Maybe you guys know actually the two different teams. It's like all the robot picture that you may see into the Starknet ecosystem. So basically, with my team, we've been spending the past 2 years on trying to build around what we call non-fungible assets. So basically, in the alternative economy that we know into the blockchain, we think there is two typology of assets: fungible ones and non-fungible ones. Correct. And so specifically, us, we think that we have a high interest with the team to build around non-fungible ones because we think it can relate to a lot of like use cases that we think are interesting for the future, specifically gaming, finance, collectible arts, whatever. Actually, we think there is many of different use cases that have not been explored yet and that will be coming in the future. We just want to enable this to happen. So basically, we have been spending like the past 2 years on B2C projects. So we've been in forefront trying to use the NFTs into the project themselves, and we've been like with this on Ethereum layer one mostly actually. And this is where actually we realized like all the constraints of the ecosystem and what was missing and what would be better in the future if we wanted to make something better for creators. And just in quick step, so Game of Blocks was one of the first decentralized game back in 2017 on Ethereum layer one. This is one of the first project that we've done with the team. And then Evrai, maybe you guys know a little bit about this, but we was one of the top 250 collection on OpenSea back last year. And so of course, now we have like transited everything towards Starknet actually right now. So basically, when we have built those applications, we've realized like six main things that we wanted to address and that we thought was really hard and painful while we were creators. Of course, there was the aspect of the low blockchain performance. So every time it was really slow to put in place any projects. We have always these high gas fees, and I guess us as creators, like we've been spending so much money onto it last year, especially. But I guess as well some people from the audition has done as well. We've seen as well a lot of problem on our side and our perspective on the fact that it was really hard to onboard people because the user experience was really rough and really bad. And of course, we don't think that, I don't personally think that self-custodian wallet is made for everyone. That's my opinion. And then on the market side, we have like disparate standard for marketplace and royalty. So we saw, really different royalties way of doing things on OpenSea, Blur, and all those things that happen. We could get a little bit into it a little bit later. And asset interoperability, we saw it's really hard as well to interact with the assets and as well with the marketplace data accessibility, specifically on OpenSea. If you guys were there back then, it was really hard to get the APIs to try to get the information from there. And so basically taken all of those things, we understood that we've done application, but we understood well what it took to build good infrastructure. And so we started, slowly to try to imagine and think all the infrastructure that we needed to be able to build the best application, because basically all the time we had as well to build both the business and the infrastructure. And so this is how the ARC project was born. the ARC project, which is basically the infrastructure that we want to provide on Starknet that will be supposed to bring, a much better environment for creators for the future. Thus our talking point. So basically, we think that Starknet is the best place for us to build, of course, because we think it's the best way technically to scale Ethereum. We think account abstraction will bring huge mass market adoption, specifically because we think like eventually ecosystem wallet could be a really good thing, a really good way to do it. And of course, we know there is a lot of great builders around the space, and it's just keep increasing every day. So we feel really glad to be part of them. And so this is what we want to do. So we want to give the creators the good tools to be able to provide the best experience in this through Starknet. So just to maybe explain a little bit about the story, and I'm just going to try to get into it, but let me know if you have any question, by the way, guys. I don't know if you wanted to, if I just keep going through, or if you want me to answer some questions. But so basically, if I give more the storytelling of how Ethereum worked, basically at the beginning on Ethereum, there was no kind of a vision to where we should bring non-fungible asset towards. So there was nothing much. And so what started to happen is like we started to see competition coming into Ethereum, and we had OpenSea, Blur, and many other marketplaces that came in, and they all tried to do the same thing. Basically, they all tried to absorb the liquidity in a centralized way. So I don't know if you know really well how marketplace works, either exchange or marketplaces, but it's always pretty much the same thing. You have the interface. So OpenSea has its own interface, Blur has its own interface, and there is a technology which is underlying, which is called the order book. And so the order book is basically the tool that manages the offer and the demand and make them match together and exchange them. And so basically, there was a lot of bias by having all those competitors trying to fight for the same market shares on different order book, because like you saw, there was different prices on OpenSea, different prices on Blur, floor price, bid, selling price, and so it was a really inefficient market overall. And as well, we saw a lot of like bad aspect of it by seeing that, for example, OpenSea and Blur decided to put the royalties of the creator down to 0% almost. And so basically, we really realized that it was highly centralized and not good at all in our perspective for creators. So basically, what we say is like with the team, we said we know this is the case this way, but it doesn't matter because we think anyway where the place is going to be for mass market is going to be on Starknet, because the gas fees are going to be much less important. So the performance of the infrastructure will be much better. And anyway, the market on Ethereum layer 1 is already fragmented, so we can't do much anything about it anymore. And basically, so what we're gonna try to do with our team, what we're gonna try to realize, like we are going to build on Starknet a decentralized order book that is actually supposed to be not binded to one interface, but that will be able to be used by every interface. So basically, you're going to be able to have a marketplace. You're going to be able to have a marketplace into an application. And whenever you are going to actually mint an NFT on one place, everything will be visible on every marketplace of the ecosystem. So basically, this is how we create interoperability. This is how we create as well, the capacity for people to have access to much more liquidity and have known the fragmented liquidity in the space. And what we're going to do, we are going to enforce the royalties into the market, into the order book. So this way, when creators will be saying, for example, I have 5% fees that I want to sell my assets, whenever it's going to be on the other marketplaces, the royalties will be enforced. So everybody will have to pay the same price everywhere. So basically, we create a market which is much more efficient, which is much less, and which is much better as a business perspective as well. And so this being said, so we are going to build the API, SDK, and Oracle for every project, marketplaces, to build their own marketplaces into their own application, be it like a bulk marketplaces, or be it for gaming companies, applications, financial, social. That will be able to build them everywhere. And one thing that we are about to launch right now, so I don't know if you guys saw recently that there was like Mint Square that unfortunately will stop to be running by the end of the month. And so it's pretty challenging aspect for us because we want obviously to be the NFT ecosystem to be striving on Starknet. And so what we've decided to do is like we had this white label marketplace that was supposed to be the place where people would directly from the white label marketplace have the decentralized order book integrated so they could bootstrap much faster their own application. But with what's happening right now with Mint Square, we decided to focalize on the white label marketplace. And so we are going to build the marketplaces that will be open sourced afterwards, and that will be connected to the decentralized order book. So in 15 days, for a month from now, we're gonna be able to release the marketplace and to be able to provide a good alternative solution for from the fact that Mint Square will be stopping. So that's kind of the big overall perspective of it. And then of course, the people will be able to use our infrastructure, and based on this infrastructure, they will be able to have account abstraction, and then have their own application in gaming, DeFi, social, whatever, to implement NFT marketplaces into their own applications.
Thanks, Brian. I think if you have any links through which people can interact with your project, or anything else that you have for folks, you can also share with me, and I'll post it on the YouTube stream. So when people are watching the recording, etc., they can always take a look.
Sure, pleasure.
Right. Thank you so much. Yeah. Thanks for coming on the workshop today, and best of luck for your project.
Thank you very much.
Yeah. Thanks. So, all right. After the special guest, now we get started with our ERC721 workshop. I'm myself super pumped for it. I've installed everything and kept my VS Code open. So I'm gonna be coding, hopefully along with Robert. But first off, I want to thank Robert for coming and doing this workshop for us. He has been a super amazing contributor to the Starknet ecosystem, and he has contributed to both Basecamp and is contributing to the wtf.Academy as a Starknet contributor. He's currently working as a blockchain engineer at Xtropy.io, a blockchain consultancy company. And of course, you're familiar with me. I'm Gyan. I'm one of the dev advocates with Starkware. And without further ado, let's get started with our ERC721 workshop.
Thank you very much for the introduction. Just give me 1 second to share my screen. Let's see if this works. Okay, cool. Everything is working, right? Everybody can see it. So, hello everyone, my name is Robert, and today we will start presenting the Starknet ERC721 workshop. You will see that this says part 1, mainly because this workshop will be divided in 2 parts. The first part will aim to focus on more of the introductory level of the ERC721, how to set up the contract, understanding the basics, how to create, implement, and deploy your 721 contract, and finally interact with the evaluator that we created. The second part is still a work in progress, but it should be released by the end of this month. The second part will include more advanced features such as mean price, attributes to the 721, or let's say NFT, and how to have it deployed on a marketplace as well. So to start with, before you start this going into the exercises of the evaluator, first we'll have to understand the interface a little bit. So I've tried to explain everything here in the README file, what you'll have to follow. Again, this you can follow along if you go to the Starknet ERC721, and you will see there's basically a draft PR in progress, but this should be deployed. I mean, this should be merged to the main branch by the end of this week. We're working on improving some of the descriptions, but yes, if you want to follow along, you can see it from here. Good. So to start, basically we'll have to understand a little bit the interface of the ERC721, and you can find this into the source folder if you go here, and then the ERC721, and here you should have the interface itself. These are the function names for the ERC721, and also when you're creating your NFT, you should also follow along with the same naming as the evaluator uses these functions. And if it doesn't, if you name, for example, you have the get name some name differently, then the evaluator will fail if it tries to call this name and doesn't find it. Good. So kind of like to explain here, it's pretty straightforward. The get name function basically returns the name of the NFT that you provided. The get symbol returns the name of the the symbol of your NFT. The owner of, if you provide a token ID with the wtf.Academy type, it will return the contract address of that token ID. The balance of function basically will have as a contract as input, and then it will return the number of NFTs owned by that account. The approve function is what the approve function does is it gives permissions for a certain token ID or a certain NFT to a certain contract address that you provide. Set approve for all function. It gives permissions to interact with all the NFTs for a certain contract address that you provide. Get approved is a function that if you provide the token ID, it returns the contract address who has the permissions for that certain NFT. Is approved of all. Again, you have to provide the contract address, and then from that you'll receive if that certain contract address has the permissions. Now, the last three functions are the mint, which basically is used to mint the NFT itself. The burn function burns the NFT if you provide the token ID function, and then the transfer of from if you provide the sender and then the receiver with the token ID. That's the transfer from function. To get more details about it, you could definitely follow along Open Zeppelin's documentation. They provide a very good overview of how an ERC721 should be set up. With that being said, this workshop, it mainly focuses on kind of like understanding the basics. So we won't focus on the security aspect of it. So if you want to understand the security aspect of it, definitely follow along Open Zeppelin's standards. I know they're working on their own implementation of the NFT itself, so you have to check their GitHub. But yeah, cool. What are the steps? So we have two contracts. Mainly, we're gonna deal with the evaluator. So you can follow along on the Starscan or Voyager link, and I have it open. I think this tab. And then the ERC20, which is the points counter, and basically these two contracts. So this is the ERC20, and this will, if you go to the read-write contract and the read tab, here you can get the total, the balance of your points. So if you validate an exercise, then you're gonna you add your address here, and then you're gonna get the total points that you have. And then this is the evaluator itself. You go again to the read-write contract, and then here you have the read and the write tab. And I'll start explaining these functions in a minute. So these are the whole exercises that you have to basically solve for yourself. But yeah, what are the task lists? So what we will focus on, we have 6 exercises. So part 1 is divided into 6 exercises, and Apologize for my voice.
Robert,
Yeah.
sorry, a quick question. Could you share the link to this with me so I can put it up for folks who might want to just like do it
Yeah,
along?
definitely.
No?
Yeah, yeah.
Okay. Thank you.
There you go.
Yeah, sorry to interrupt. Please continue.
Yeah. Okay. Cool. As I mentioned, it's divided into 6 exercises. Each exercise has 2 points attributed to it. So if you correctly do it, then you're gonna receive 2 points, and then you can check with the um, points counter. The links are here, and then you can check if you receive those points. So for the first exercise, what you need to do is to initialize, to build your constructor function, and the get name and the get symbol function. And this is what you have to first define in your ERC721. Then you'll have to interact with the evaluator, and then this exercise actually we'll do together. So maybe I'll just skip through it, and then we will see how we do this together. But just to say, you'll have to go through the evaluator, you have to access the get user slot function, and you'll receive a certain user slot number. And that user slot number, you'll have a specific name and symbol attributed to that number. So it's a bit complicated, but with that name and symbol, that's the name and symbol that you have to initialize your constructor. This is to kind of like introduce a bit more randomness, or not necessarily randomness, but it's a bit more dynamic. So yeah, you can name the your NFT by that. Then you have to deploy it. You'll have to call the submit exercise, and then you can call the exercise 01 initialize, and then you'll receive the points. Second exercise focuses on minting of your of the NFT. You can follow along the bullet points here. The third exercise is burning of the NFT, where you have to create a burn function, and then you have to deploy your contract, and then again submit the exercise, and then validate your contract. Fourth exercise is approving the NFT. So this is where you focus on the approve function method. And the fifth exercise is approve all function, where you have to set up the set approve for all. And then the sixth exercise is transferring the token with the transfer from function. Yes. So, and then there's some little bit details, like if you want to contribute to these workshops, feel free to do so. And there's also other automated workshops. But yeah, let's try to get into it, right? So give me 1 second. So first of all, like if you want to kind of like understand what's happening for a certain exercise, what you can do is you'll go straight to the evaluator, and then here, let me know if the font is big enough for everybody to see. Yeah. And what you can do is kind of like go through the evaluator itself, and then see what happens here. So for example, the first exercise that you'll have to complete is the initialize function. And then what happens here is basically the evaluator checks the submitted exercise that you did, receives the the address that's being called from, and then here what the evaluator is doing is it's getting the name from the submitted exercise that you submitted. So that's why I said like you have to follow the names in the interface from the ERC721. It receives the name and the symbol, and then here we have the assigned user slot that you have, and then based on that user slot, each user slot has a unique name and symbol attributed to it, and then we do a bit of assertion here to check if the symbol and the name is correct. And then if those are correct, then the exercise is being validated and the points are distributed. The same thing goes for the minting function, but feel free to look at these functions and interact with them, try to understand what's happening here, and yeah, I think from here we can start going into some to do our first exercise. So I already have prepared I have already initialized my project, but if you're not familiar how to initialize your project, you can use Scarb. It's a package manager. It's a very good package manager. And then, once you create your folder, you can just call Scarb init and then initialize your folder structure. And it creates lib.cairo, a Scarb tunnel, and from here you can create additional Cairo files. What I did is created the ERC721 Cairo, and I've imported this in the lib file. And well, here I'll start building my first NFT contract. Before this, make sure to I think I'm not entirely sure. I think we are on Scarb 0.3. So on Scarb 0.3, you'll have to state your dependencies as such with Starknet, and you have to say the version that you're on, and then you have to say the target Starknet contract. Cool. Everybody's following along, or if yes, then it's perfect. So first of all, as I mentioned, we'll have to let's go back to exercise 1. And then if you follow here along, you'll see that we'll have to create the get name function, a get symbol, and also a constructor function, right? So to do this is what we're going to do is first we're going to have to state we create a storage. So we say storage, and then we spell storage. And then we're going to say name as file252, and then symbol as file252. And of course, like as you go along the exercise here, you'll have additional variables that you will have to define. So okay, now you have to create the constructor function. So we'll start by creating the constructor function first, and then let's define the constructor. And then in the constructor function, usually what you initialize the contract with is with the name first. That's file252. And then the symbol, we say with we use underscore because it's good practice to define them like that, because later on you will see that you might use the same variable to write to the storage, and it might get confused at one point, and yeah, it's good practice. In the constructor function, what we're gonna do first is well, we receive the name and the symbol, and then here we want to write these inputs to the storage itself. So what we're gonna do is do name write, and then we're gonna say the name itself, and then symbol write, and then symbol. Okay, and that's it. We're almost done. I mean, the constructor function is done, but now we have to create the view functions as well, so that we can check our name and the symbol has been attributed. So to do that, we created the view function, and then we call this fn. And then here you have to follow the interface that was here, right? So you'll see you get name, and then this interface also says like what type of variables are as inputs and what you should get back from that function. So we have get name and get symbol that we have to say. So get name, and then as a return function, we have file252. And then what we're doing is we read the storage, and then we return the function. We don't put a semicolon because if we would put a semicolon, then we'll have to say return name. So if we don't put the semicolon, automatically returns the value. Finally, we're gonna create the symbol, get symbol, 52, and then we have symbol read, and this is where we read from storage. Cool, and that should be it for our first exercise. This is how your first exercise looks like. But again, before actually deploying the contract, make sure to go through the evaluator first. I think I have a dummy wallet set up. Let me just quickly check. Yes. So you go to the evaluator, and then once you connect your wallet, first you have to assign a user slot. And then from that number that you're assigned, you'll have to retrieve your name, your specific name and symbol. And if that information is going to be used into building your constructor. So if you haven't, so for example, if you haven't assigned the user slot, what you can do is maybe let's say you're gonna try to call the first exercise, but it's gonna throw out an error. The transaction failure predicted, and there's a certain failure reason. Well, the hex is not really understandable. What you can do is there's a tool that I use. I think you can get it from here. So Stark Utils. I can probably drop this as well in the.
Yeah, that would be helpful.
There we go. This is a useful converter that helps you convert anything. The hex is automatically converted into file, string, and whatnot. So again, we take that. I think I already pasted this in. So if I take this and I put it here, you're gonna see that the equivalent in string, it says assign user slot first, right? And then if you want to kind of debug the process of it, what you can do is you go back to the evaluator itself, and then let's see. So we say here verify. There's this line. There's a function named verify, and then if we go to that function verify, let's see where the verify is. I think it's at the end. Here, this function is called, and this function basically checks if you have an assigned slot, and if you don't have that, it's going to throw out an error that you have to assign it first, right? And then similarly for if you haven't submitted a solution and you try to invoke that function, you're gonna get this error. So you can go through, debugging the contract like this as well. Okay, let's see. Go back to the evaluator. This failed, so because we haven't assigned the user slot first. So what we're gonna do is first do that. And it's gonna take a couple of seconds, I guess. And then just to mention, the constructor update class set random names and set random symbols are functions that are mainly for the admins to set up the contract. The only functions that you will interact with are everything that's named exercise 01, 02, and so on. The submit exercise and assign user slot, and then in the read tab you'll have to you will see that you have a get user slot, player exercise solution, and then these are the two functions that you will retrieve your name and symbol. So now we'll wait for the transaction to be approved. It takes a bit. So anyway, so let's say I know the account will take let's say you go to and then until it's already submitted. Okay, perfect, cool. So I'll take my address, I'll put it here, and I'll check what what user slot I have assigned. So it's 2, right? So for that, I go here, check exactly what's the name I have to use and the symbol I have to use. Now, and these are the two, the name and the symbol I have to use, and this is what I have to initialize it with. So I'll grab the hex version of it and go back to my function that or the contract that I created. And then right now, like let's try to deploy this contract. So for that, I usually use makefile to kind of like have shortcuts for my functions. But what you can do is, if you're not familiar with the makefile, then you can create this. It's very simple. But you can also call the CLI directly and say Starknet. Actually, first before I do that, we have to build with Scarp the contract itself. So let's do that first before declaring, because we don't have anything to declare. So with Scarp build, you'll see that you have a target folder, and then in the target folder, in the dev folder, you'll have your Sierra file. And this is basically the build that you receive from Scarp. And this is the one that we're gonna first declare it and then deploy it to the testnet. So we'll go back to makefile, and what you can say here is it's either Starknet declare contract, and then we're gonna say that the folder location or the file location, target, dev, and then here we have ERC721 file, and then you have to state the account that you're gonna deploy with, and that's it. Show trace is not necessary. Show trace is very useful if you want to debug a bit if something doesn't go accordingly. But yeah, so if you first time build it, and it might declare successfully, you won't have this error. But what this error means is that I've already created this this contract, and this class with the hash already exists. So this is nothing to be concerned of. What you can do is just copy the class hash, and then you can use this class hash into the deploy function. So Starknet deploy class hash, and then we say the class hash that we did, account version 2, and then give me 1 sec. And then here we're gonna state the inputs, right? And then it's it's useful to, I mean, it's easy to get them as hex from here if you have already like an assigned user slot. And then you have to follow like the order that you set, like name, it's the first, and then the symbol the second. Make sure to follow along. And then we take the symbol from the get info symbol. And that's it. I should be able to deploy this. Okay, and it's already deployed. We'll have to wait a bit until this contract has been deployed, but I've already deployed something like this in advance. That's why you see this error in the first place, because it says class already deployed or declared, sorry. So I have my contract address here. This is the one that I've deployed earlier. And I think it's open here, right? And then you can see that the get name and the get symbol that we created, and the constructor, obviously. And if I go here and I query this, you'll receive the ERC721 workshop 2. And this should be similar as the one that was assigned to us, if I'm correct. Yeah. Okay, so what we're doing now is take this contract, and you can go also to the overview and then copy it from there. Go back to the right tab, connect first my wallet. And now what I want to do is submit the exercise. I submit my exercise. The exercise is the contract that we created and deployed on testnet. and should take a bit, 30 seconds hopefully. And then once this has been confirmed, I mean, we can follow along if we want to. Until then, maybe we can talk about something else until it's confirmed. Yeah. So make file like yeah, that the reason why I say it's very useful, because you can say like make Starknet declare, for example, and then here I just have to, for example, say the file equals to, and then or actually let's do deploy so it makes more sense. Deploy, and then hash equals to, and I'll take this. Where is the hash? This one, right? And I say this hash, and then automatically runs the same function, and it's super fast. So it's useful to have it. Let's see if this has been confirmed. Not yet. Not yet. So any questions until then, or do we have any questions until our transaction is being confirmed?
Yeah, I don't see anything on the YouTube yet, but maybe what another thing that I can share is that like how Robert is doing the exercises by sending in some value and getting some inputs and things like that. Um, as he mentioned earlier as well, you can also do these exercises on your own. And if you complete the exercises, you will be getting some points. So once you start doing it, it's quite addictive to want to get to the end and to want to get all the points. So that will be very interesting. And the idea is throughout the exercise, at every step of the exercise, you would get to learn about different elements of writing a Cairo contract. So that's a really fun way to learn. And we have some other exercises as well, not just ERC721, but Cairo 101 exercises, which you can look at right now to just understand the basic syntax of Cairo. How do you write functions in Cairo? How do you return values in Cairo? How do you take in arguments in Cairo, etc. So you can start with this one, which is the Starknet Cairo 101 automated workshop, and then make your way through the different other tutorials that are there, like the ERC721 built by Robert. Then there's going to be a messaging bridge tutorial that's also built by Henri from our team, which is going to be live soon. So these are some of the interesting things that will help you hopefully pick up your Cairo skills in a fun way.
Thank you for that additional information. Definitely, Cairo 101 is a very good place to start, and I really suggest that. I did it myself, and it's a very interactive workshop. So, I think our transaction was finally confirmed after a century. So let's try to see if we managed to do it correctly, right? So we go back to exercise 01, and then what we need to do is like the final step from if you read the README file, like here we already called the submit exercise, and then finally we just have to verify if our contract has been deployed correctly. Now we're gonna just press the right button, and seems like we don't have any failures, which means that we correctly initialize the contract with the correct name and correct symbol. And once this transaction has been confirmed, we can go back. Actually, let me do that now so you can see the difference. We can go back to the ERC20, and then if I query this, it should be 0. But if we wait for a little bit, then it should be, we should receive some points. Let's see. Yeah. Yeah, again, we have to wait a couple of minutes. But going back to the workshop, the 101, it's a very good place to start. And then the 721 workshop, it's a very good place to continue building your skills to learn how to deploy and build 721. The second part will be even more interesting, because we will implement more advanced features that you can use with Cairo1, but also you can also see and interact with your NFT on the marketplace itself. So that was going to be exciting. Cool. Seems like our transaction got deployed. I'm gonna query again the balance off, and we should see that we received 2 points, or I think this is in Gwei, so that amount of points. So I hope you like this exercise. I really invite you to go through all the exercises where you learn how to mint, burn, approve, and so on. And if you find it interesting, make sure to leave a feedback. If you have anything else that you want to explore, let us know. And yeah, thank you very much for this opportunity to showcase the workshop. Are there any
Awesome.
questions?
Let me check if there are any questions. No, there's just some conversation on TPS. So
No.
I think we are good. Thank you so much, Robert. Thanks for your time and basically building this entire really cool tutorial where people can, learn about ERC721, especially in Cairo, and also get some points. So that's super cool. And yeah, and we hope that all of you are able to solve these exercises. I've posted the link to the exercise on the YouTube live, so you can pick up the GitHub repo from there and you can start getting those points. If you have any questions, you can also reach out to anyone from the dev advocacy team on Discord, or you can also reach out to Robert. So Robert, if you have any any social links that you want to share as well, please do so with me, and I will share that on the YouTube live stream as well.
Yeah, the only one is my Twitter account, so feel free to reach out to me there. Otherwise, I'll be hanging in the Discord channel and in the Starknet Discord channel. And yes, I do want to say that I would like to thank 0x Kubitus for helping contribute to the workshop itself. And I also invite everybody from the community to get involved, contribute, and build workshops and fun exercises together. Because like this, we build the community. It's making more interactive and fun. So yeah, I would like to thank everybody. Thank you.
Yeah, amazing. Thank you, Robert. And yeah, feel free to contribute to this existing repo or any other fun new exercise that you do want to build on. Cairo1 is fairly new. So we are looking for contributors who want to learn and also contribute back to the ecosystem. Thank you so much once again, Robert. And this was workshop number 15. We'll see you in a community call next Tuesday. Thanks, everyone, and have a good day.
Thank you, everyone. Bye bye.
Bye bye.